In this section, you're given a couple of limits, and we're going to use those two limits as fact. The first one says the function sine of x over x goes to 1 as x approaches 0. You could graph this function if you'd like, and you would see that that would be the case. There are also some proofs available to you in the book, but we're just going to use this as a fact. The next limit for this section says that we have a function cosine minus 1 divided by x. That function goes to 0 as x goes to 0. Okay, and we're given this function down here, and we need to find the limit of this function as theta goes to 0. Okay, so the first thing you should do with the limit is see what happens when theta equals 0. Well, we can just think about it. If we plug theta equals 0 into this function, we get cosine squared of 0 minus 1. That's 1 minus 1. That's 0 in the numerator. And looking at the denominator, we're going to have 0 as well. So that's 0 over 0. That's an indeterminate form, meaning that we're going to have to do some algebra. Well, I'll show you two different ways to do this. But the first thing you might think is that these two functions look pretty similar. Yeah, this one has the theta and this one has an x, but that really doesn't matter. The big difference between these functions is this square. Unfortunately, that really screws things up as far as using this given limit to find our limit. But you might look at this function and think to yourself, this looks like a difference of squares. I know that I can factor this cosine squared theta minus 1. Cosine squared theta minus 1 factors into cosine of theta minus 1 times cosine of theta plus 1. Now we have a piece of this function that looks exactly like the given limit above. Let me just rewrite this. Now we can see even more clearly that the limit of this piece of the function is going to be 0 because that limit is given to us above. What about this piece of the function? What happens if we plug in theta equals 0? Well, cosine of 0 is just 1, so we're going to end up getting 0 times 2, and our limit then is just going to be 0. Okay, that's a pretty good answer. Let's try it using another method. You might remember that cosine squared theta minus 1 is a common trigonometric identity. It's called a Pythagorean identity, and that identity looks like this. Moving some terms around in this identity gives us that the numerator of this function can be simplified to negative sine squared theta. And you'll notice now that this function is starting to look a lot like the given limit over here. Let's use just a little bit of algebra to make that more clear. Sine squared theta is just sine times sine. So I'm going to split those two sines into two pieces. Now let's see if we can take the limit. We're given that the limit of this piece of the function as theta goes to 0 equals 1. But what happens to sine of theta as theta goes to 0? Well, sine of 0 is just 0. You'll recall from your trig class. So the final answer is going to be negative 1 times 0, which again is just an answer of 0. So okay, we did that problem two different ways. One used factoring, one used the Pythagorean trig identity. In both ways we got the same answer, so it looks like math still works. Let's test math out again in the next calculus problem of the day. I'll see you tomorrow.